The third question of interview questions. Memory layout of a C program. First, look into this diagram. You can notice we have a text section at the bottom and initialized data, uninitialized data, or it is called as BSS. And this two data segments together form a single segment. And then you have a heap and a stack. A stack and heap and stack always will be in the opposite direction. And this top one is for command line arguments and environment variable. Now let us discuss deep into it. Now what is this text segment for? Text segment is a read-only segment which contains executable instructions. And this segment is below heap and stack so that overflow in it doesn't affect the segment. In a program, a overflow can occur. So if the text segment is above it or placed somewhere above, the overflow can affect the program or it can overwrite it. So that's why we have our text segment as one read only, so that it can avoid overwriting or some other effects. And this text segment is shareable so that a single copy is needed in a memory for frequent execution. Like once you compile and you run it many times, or you can use the thing in text editor or in shell mode. Then next comes the initial data segment. This is the initial data segment. Initial data segment. This segment contains a global variable and a static variable which are initialized by the programmers. If you write static I equal to 10, then that value will be that the value or the variable will be allocated inside this initialized data segment. And it is not a read-only segment because the value in the variable can be altered at the runtime. Uninitialized data segment. This is something interesting, and we call this segment as BSS segment. This segment contains a global and the static variable. Okay, you can say both the thing contains a global and static variable. Now what is the difference? The difference is that in this we initialize a variable with a global globally or with the keyword static, but we don't assign any value to it. So if we don't assign, the kernel itself assigns arithmetic 0 to these variables. So this variable will be stored in uninitialized data segment. Now next comes the stack. The stack segment stores all local variables along with the information saved each time when the function is called. And you can also imagine about a recursive program, and a recursion works using a stack. And this is how a recursion in a C works. When a function is called, a new memory or the stack frame is allocated for auto and a temporary variable so that the function variable does not interfere with the another instance of another function. Now next comes heap. A heap is a segment where a dynamic memory allocation takes place. It is placed above the BSS segment, and this segment is managed by malloc, clloc, realloc, and free. And then about the stack, when a function is called, when the function gets executed, the local variable inside it also gets destroyed, and that function, when it is over, it will be removed from the stack and then it comes for the next function. So this is how the stack works. Thank you.